In this video, we're going to be starting quadratic functions, and we're going to begin with the standard form of a quadratic function, which is written here. A, B, and C are all coefficients and numbers. A is always in front of the x squared, B is always in front of x, and C is always the number that's added by itself at the end. Now, when you look at a quadratic function, you can tell certain things just by looking at it. So let's take, for example, this one. X squared plus 2x minus 5. I can tell just by looking at this that it's going to have an intercept at -5, so somewhere down here, and it's going to open up because my a value is positive. So I end up with a quadratic that looks something like that. I'm not being exact here. One that opens down might look like this. And because this is negative, I can tell right away that it opens downward. So if I were to sketch a quick graph here, it intersects at 7, so somewhere up there, and kind of, well, there we go, better. So it looks something like that. So if your a value is positive, it opens upward, and it's shaped like a U. If it's negative, it opens downward. Now, parabolas are symmetrical, which means if I were to divide these lines in half through the vertex, remember your vertex is your turning point. If I were to divide it in half right about there, my points on either side would line up. Same thing over here. If I were to do a vertical line through the vertex, my points on either side would line up. This line is what we call the axis of symmetry, or line of symmetry. And the formula for the axis of symmetry is x equals -b over 2a. A and b, remember, are your numbers up here. A is in front of x squared, b is in front of x. Now, I can also tell whether a quadratic is going to have a minimum or maximum by looking at the graph. And the way we tell that is your a value positive or negative? Again, if it's positive, it opens upward, which means the vertex is your lowest point. And because it's the lowest point, the vertex is a minimum. If your a value is negative, it opens downward, and your vertex is a maximum. So let's take a look at just a couple of problems, a couple of examples, and tell some things just by looking at the function. So let's take f of x equals -x squared plus 6x. Okay, let's get this up a bit. I know right now that because this is negative, the graph opens downward, which makes my vertex a maximum. So I can tell that just by looking at the equation. I can also get from this the axis of symmetry. And the way I do that is I look at my a and b values. In this case, my a value in front of the x squared is a -1, and my b value is a 6. So if I take -b over 2a and plug these numbers in, I'm going to be able to get my axis of symmetry. So -6 over 2 times -1. Well, that's -6 divided by -3, which is positive. I'm sorry, -6 divided by -2, which is positive 3. So my axis of symmetry is x equals 3. I can also get my vertex. Now, for my vertex, I already know what the x value is. The x value is the x from my axis of symmetry. To get the y value, I'm going to have to take this number and plug it into the original. So negative 3 squared plus 6 times 3 will give me my number. And it ends up being 9. So the vertex is at 3, 9. Now, what happens if one of these values is missing, though? So let's take another example. G of x equals negative 2x squared plus 7. Okay. Actually, let's make this one positive, just because I can. Make it a little bit different, a little bit more different from the other one. On this one, because it's positive, I changed it. It opens upward, which means the vertex is going to be a minimum. For the axis of symmetry, again, it's negative b over 2a. Well, let's look at our a and b values. Our a value is positive 2. The b value is 0. Because the b value is 0, well, negative 0 was just 0 over 2 times 2. It doesn't matter what the bottom is. 0 divided by anything is just 0. So the axis of symmetry is x equals 0. So going to my vertex, I'm able to go ahead and put in the x value because it's the same as from the axis of symmetry. So to get the y value, you must plug it in. So 2 times 0 squared plus 7 gives me 7. Now let's talk about how to use this information to graph quadratic functions. And I'll go ahead and keep those same ones for now. So the first one I had was negative, rewrite it real quick. First one I had was negative x squared plus 6x. What you have to do is you have to make a table of values. We know the vertex already. It's the one we just did, and our vertex was 3, 9. You number down and up from there. Now, you can plug it in one at a time. I'm going to be a little bit lazy. I'm going to go ahead, type in negative x squared plus 6x. And then I'm going to go and look at the table by hitting second graph. And if I move this a little bit, I'm able to get some points that I can actually plot. So I'm not going to write out all these points, but I've got a point at 0, 0. I've got a point at 1, 5. 1, 2, 3, 4, 5. At, what is that, 2, 8. 3, 9, which is our vertex. And then it's symmetrical, so on the other side it's same y values, just further along. So I'm able to graph it using that. Now, let's talk about domain and range for these. Domain, because my ends keep going, my domain is going to be all real numbers. For my range, though, there is a limit to how high my y's go, and that's the y of our vertex. And because the vertex is a maximum, it's your highest point, all my other y values are going to be less than or equal to that y. So the other one we had was g of x equals 2x squared plus 7. And again, we've already looked at some of the information on that, so I'm just going to go ahead and type it in. 2x squared plus 7, and then graph it. So I can get some points from here. And I can really only graph 3 of them on this one. I've got -1, 9. -1, 9, 0, 7, and +1, 9. So I have this parabola here. Domain on this one is still all real numbers. X, Y, X's go on forever, left and right. For my range, the Y value here it's your minimum. It doesn't go any lower than that. So all your Y's are greater than or equal to 7. So let's look at a couple of problems where we we hadn't already worked it. Excuse me. So let's take less than, and I'm going to do an inequality this time, add some more new stuff. X squared minus 6x plus 11. I'm going to find my vertex first, that way I know where I need to center my graph. And I found the vertex by doing -b over 2a. And this one is a good one to show you because I have not yet shown you one where we had a -b value. When we go to do the b value, well, it's -b, so -6. But remember that a double negative is positive, over 2a, and our a value for this one is 1. So I get +6 divided by 2, which is +3. So my vertex starts at 3. The x value is 3. So I know when I go and use my calculator, I need to make sure that 3 is in the center of my table. So type it in, look at the graph, and move it down to where 3 is in the center. And I can see that I did not type this in correctly. Try that again. There we go. 3 is in the center and the numbers are symmetrical. So I can use that to get my information. So vertex is at 3, 2. So 3, 2. And I can use my other points. So I've got 2, 3. I've got 1, 6, 3, 4, 5, 6. And on the other side it's symmetrical, so there we go. Now, solid line, because it's less than or equal to, so solid line here. And I shade. Because it's less than, I'm going to shade below the vertex, which is this side. Now you might be asking, if our calculator does all the points for us, why even bother using the -b over 2a? Well, sometimes you get something that looks like this. And let me switch up real quick. Let's talk f of x is greater than -3x squared plus 18x minus 22. If I were to type this in to y equals on the graphing calculator, and then look at the tables, let's see. Oh, I chose the wrong one. This isn't the one I meant to do. Oops. Okay, sorry, one sec. -2x squared minus 2x plus 1. I'll just do a different one. Start from scratch. Okay. So negative 2x squared minus 2x plus 1. You can see when I look at the table, yeah, the numbers repeat, but there's not really one in the middle. That's because the x value, where the vertex is not a whole number. So you can set your table to do fractions, but you don't really know what fraction it is. So it's important that you do the negative b over 2a. So negative b, which is negative 2, over 2a, well, a is also negative 2. So this gives me positive 2 over negative 4, which is negative 1/2. So my vertex, the x of my vertex is negative 1/2. And I have to go ahead and figure out what that is going to be for the y value. And again, you do that by plugging it in. That's what the table does for us. But in this case, because it wasn't showing up on the table, we're going to do it this way. I'm just going to do 0.5. It's the same fraction. Plus 1. So we get 1.5 for the y value. Alright, so negative half and then 1.5 is right about there. For my other points that I can plot, I'm using my little table here. I've got negative 2, negative 3. Let's see, negative 1, 1, and that's probably good enough. So 0, 1, and then that. Okay, so a little bit different because the vertex was, well, not on one of the crosshairs. So dotted line for this one when we do our connecting the dots bit, because it's greater than, and because it's greater than, we are going to be shading above the vertex, which is on this side. Alright, I think we're going to stop here for today. Just be careful. Calculators are convenient when we're trying to find a lot of points, but it's not always perfect, like in this last example. So make sure that you use the negative b over 2a to get your vertex, and then go through and use the rest of it. Alright, see you next time.